Okay, so we're going to start with graphing. You don't really need to write down these steps that are listed here. Some of you are like, oh, I already started. Sorry. You don't really need to write these down. These are just really all the pieces and parts of a quadratic that we're finding to be able to get a complete graph. So we find which way it opens, which we talked about yesterday. You could even do domain and range, min and max. That all kind of goes together. Then you can find the vertex and axis of symmetry. You could also find x and y intercepts, which is a review topic for us. And then when you put all those things together, you get a decent graph. Now, do you need all of those things to get a graph? Probably not. At minimum, you need a vertex and you need a point on either side of the vertex, and that would give you a nice picture of a parabola. But many of your homework problems when we get to tests and quizzes are going to ask for all these pieces, so we're going to practice getting all of them. Okay, so we are going to start with this problem, and then we'll do one in the other form on your big idea worksheet in a minute. So this is our standard form, remember, from yesterday. Y equals -2 x plus 1 squared plus 3. And we're going to find all the pieces and parts, put it together, get a decent picture. So first thing I'm going to do is find the important variables or coefficients that go along with my form that I'm given. So depending on what form you're in, that's either A, B, and C or A, H, and K. Because I'm in standard form, it's A, H, and K that we're looking for here. Can you tell me what A is? -2. H, -1, that's always the opposite of the number inside the parentheses, good, and K is 3. Okay. The next thing that I would find is probably the vertex, which if you're in this form, the vertex is always what? H and K, which we already have. So -1, +3. Along with the vertex, you can always find the axis or the axis of symmetry or the line of symmetry. It's called a few different things. So the line of symmetry is always what kind of line? We talked about that yesterday. A vertical line, so that means it's going to start with what? X equals, and it's going to always go through what point? The vertex. So what does X equal in my vertex? -1. So it's always X equals H is what we're using for that. Okay, next thing we can find are, let's do which way it opens. Which way does this open? Up or down? How do you know it opens down? Because my A is negative. If it opens down, does it have a min or a max? It has a max. Okay, let's go ahead and find intercepts now. So that's review from way back at the beginning of the year. Let's start with a Y-intercept. How do we find a Y-intercept? 0 for X. All right, so in this equation, that looks like Y equals -2, 0 plus 1 squared plus 3. And then you can use your calculator, order of operations. If I do it in my head, order of operations, I would do 1 squared, which would give me 1, times -2 is -2, plus 3 is 1. So my Y-intercept is 1. How do I get an X-intercept? Y is 0. So 0 equals -2, X plus 1 squared, plus 3. All right, so how do I solve for X here? What do I do? So you can FOIL it out and simplify, but you actually don't have to do that here. That might actually add a couple steps to our problem. How many X's do you see there? 1, right? And if I FOIL, wouldn't I get 2 X's, an X squared and an X term? So it makes it a little more complicated. If you just have 1 X, get it alone. How do you get it alone? Start moving things to the other side. So what would you move over first? 3. So it'd be a -3 equals -2 X plus 1 squared. Then what? Guys, this should be the easy part. We should know how to solve for x in an equation. Divide by -2. There we go. Okay, so -3 divided by -2 is just going to give me 3/2 or 1.5. Goes x plus 1 squared. So now I've isolated that parentheses squared. So what happens next? Square root, and what do you put in front of your square root? Plus and minus. Plus and minus. Square root of 1.5 equals x plus 1. And then last but not least, subtract 1. So I'm going to get x equals, and usually when we subtract it, we put it in front of the plus or minus, if you guys remember doing that. So -1 plus and minus the square root of 1.5. And then that's kind of hard to graph, so let's go ahead and just approximate what those are so we can see where I'm going to make points on my x-axis. So if I do -1 plus the square root of 1.5, I get about 0.22. And if I do -1 minus the square root of 1.5, I'm going to get about -2.22. Okay. All right, so that's pretty much everything we could find here. You could also find domain and range, but we don't really need that for the graph. So let's go ahead and plot everything we know. So we had a vertex at -1, 3. And we also knew that it opens down, so I should expect any other point I plot to be below that vertex. I have a Y-intercept, a point on my Y-axis at 1. And then I have a point on my X-axis, I have 2 of those, at 0.22 and -2.22. And you should be seeing symmetry, a U shape when you're doing this. Vertex should be right in the middle. And then curve out from there. When in doubt, if you don't know how to graph something, you just make an XY table and start plotting points so it looks like what it's supposed to look like. You can definitely expect a graphing problem would be a non-graphing calculator question on a test or a quiz. You would just have like a basic calculator for anything where you're graphing. Questions there? Okay, so that's what it looks like if you have one in standard form. Now go to your big idea worksheet from yesterday. Maybe there it is. This is the general form. It's asking many of the same questions. I'm going to let you guys try it. Here's what I would suggest. The first part of the problem says to put it in standard form, and there's 2 ways to do that we talked about yesterday. Option number 1 is to complete the square. Option number 2, which is the very last thing we did yesterday, was find the vertex first and then just put that in standard form. I would say that's probably the easiest route to go, is find your vertex first, do part B, and then use that to write the equation in standard form in part A. All right, so go ahead and try it with your groups, get as many of these pieces as you can, and then we'll put it up on the board and we'll talk about it. So let's do those last couple word problems on the back of your big idea worksheet. That's going to wrap up our lesson. All right, so just a little practice here. First problem says you have 100 yards of fencing to enclose a rectangular section of a field. What is the maximum area you can enclose, and what are the dimensions of the rectangle if you want to enclose this area? So some of your Math Excel problems are going to talk about fencing and perimeter and enclosing, so I thought it would be good to kind of practice one of these. I'm going to go ahead and just sketch this out so we can get an idea of what we're looking at here. So here is my rectangular field. We don't know the dimensions of it, so I'm going to say X on either side there, and I'll say Y on either side there, whatever those are, okay? 100 yards is what as far as this fence goes, or this pic? It is the perimeter, okay? So to find the perimeter, 100, we would just add up all of our sides, right? Or you could use that formula back from geometry, 2L plus 2W, 2 times the length, 2 times the width. Either way, you're going to have 2 X's added together and 2 Y's added together. The other thing it's talking about in this problem is you want a maximum area, okay? And we don't know what that area is, so we're just going to write an area equation. How do you find area of this rectangle? X times y, that's it. So what we've created here is a system of equations, and we solved system of equations a chapter ago, right? Okay, so we want to put these two equations together. Ultimately, we're trying to maximize the area. So I'm going to solve for a variable in my perimeter equation and plug it into that area equation. Doesn't matter which one you solve for. So in my perimeter equation, let's say I want to solve for x. We're going to use the substitution method. How do I solve for x? Okay, get x alone by doing what? Subtract 2y. And then divide everything by 2, which this will divide in nicely. So it'll be 50 minus y equals x. So I've isolated a variable. X is the same thing as 50 minus y. So now I can take that 50 minus y and replace x with it in my area equation. So now my area equation is 50 minus y times y. And if I want to simplify it a little bit more than that, I can distribute, and I'm going to end up with 50y minus y squared. All right, so you see we have a quadratic. That's why this is falling in this section. We actually saw problems that had equations like that before we were able to solve them, though. Maybe like a was a number that we were able to use. In this problem, we want to maximize. Now, this is a parabola that opens down, right? Because I have an a value, the number in front of my y squared is negative. So if it opens down, that maximum point is called what? The vertex. Or anytime you want a minimum point, that's the vertex, as long as it's a parabola. So I need to find the vertex. That's going to answer my question. And I have my equation. So if I have my equation, how do I find the vertex? What formula do we use? Uh-oh. Literally just did it in the last problem, guys. Come on. Negative b over 2a. That's what I want. What's the opposite of b in this problem? Be careful. The terms are a little out of order. It's negative 50. Yep, it's at 50y. And what's a in this problem? Negative 1. So I have negative 50 divided by negative 2, which means 25 is my y value of my vertex, which is normally our x, but y is the variable in this problem. If you want to, you can plug that back in to get the other part of the vertex, or you can just go back to your rectangle. I know y is 25. My perimeter is 100. So what does that mean the other dimension of this rectangle is? It's also got to be, well, 50 total for the other two sides, right? So the other side is equal to also 25. That's all you need to answer this question. What are the dimensions of the rectangle? 25 by 25 yards. What's the maximum area? So what do? Just x times y, multiply them together. 25 times 25 is maximum area, 625 square yards, which, by the way, that's the answer you would get if you plugged 25 back into that area equation. You'd get out 625. So it gives you one of the dimensions, which this happens to be a square. The square maximizes the area. And then when you plug it back in, you get that maximum area. Okay. So toughest part about this one, I think for sure, is just getting the equation, getting that set up. But then if it's asking for a min or a max, it's just your vertex. Use your negative b over 2a formula, and then you can plug it in if it's asking for another piece. Okay. Questions on that one? All right, last one. Says, from the top of a building, a projectile is shot 400 feet high with a velocity of 64 feet per second. The altitude height after t seconds is given by the following equation. So no need to write the equation here, they're giving it to us. First thing it's asking is, what is the maximum height of the projectile? Okay, so again, we have a quadratic. It's got a negative in front of it, which means it's opening down, which means the maximum point that we're asking for is the vertex. So that's all we need to find here is the vertex. Opposite of B over 2A. What is the opposite of B? Negative 64. 2 times A, negative 16. That's negative 64 over negative 32, which is a positive 2. What variable is that in my equation? It's the x, which in this problem is t. Okay, so what is that? It means after 2 seconds, because time is my seconds there, that's when it's going to reach its maximum height. So that doesn't quite answer my question. I know it's going to happen after 2 seconds, but to find the height, that's the y variable. So we still need to go ahead and plug this in my equation. H is negative 16 times 2 squared plus 64 times 2 plus 400. And then you can use your calculator. Negative 16 times 2 squared plus 64 times 2 plus 400. And I get 464. So after 2 seconds, the maximum height is 464 feet is what that vertex gives us. So really answering that question, 464 feet is what we're looking for. Part B, when does it hit the ground? If it's hitting the ground, what's the height? Height is 0. So this is really just kind of like finding an x-intercept. Your y, or your h in this problem, is 0. Negative 16t squared plus 64t plus 400. Can you get rid of that there? All right, so option number 1 to solve for this is you can try to complete the square, try to factor it. I think that gets a little messy with the big numbers I have here. I think I'm just going to go straight to the quadratic formula because I know that's going to work. So quadratic formula, which will solve for t in this case, not an x. Where's my pen at? There it is. Opposite of b, negative 64, plus or minus square root. 64 squared gives me 4,096. Minus 4 times a is negative 16 times c is 400. All over 2 times negative 16. Let's simplify everything under that radical. I know in the denominator I'm going to get a negative 32, so let's see, 4,096 minus 4 times negative 16 times 400 gives me a number that I can take the square root of, hopefully. I think that'll work. Okay, so we get about 172. I'm just rounding there. It's like 172.3. And then we simplify once with the plus and once with the minus. All right, so go ahead and do that. Let's see what our final answers are. Hi, this is Miss McDonald. Hey. Yes, she is. I will. Emily, were you here for the first period? Yeah. Like all period? Mr. Walsh marked you absent. Okay. She said she was here all period. Yes, I will. Okay, bye. When you leave this class, go to Mr. Walsh and just remind him that you were here. Okay. Let's see what we get. Negative 64 plus 172 divided by negative 32. I get negative 3.375 for the first one, and negative 64 minus 172-ish divided by negative 32 is 7.375. Now these are T's, so they are seconds. You should get for those. Do those both make sense? They do not. Which one is our answer that we're looking for here? The positive one. We can't have negative seconds. We can't go back in time. So the time when it hits the ground is between 7 and 8 seconds. All right, so that should help you with some of your Math Excel problems. You're going to see one similar to this. You've got 15 minutes now if you want to start on your Math Excel. Math Excel 3.1 is due on Sunday night. Okay, so you can divide your time wisely for that. And then we're going to do 3.2 on Thursday and Friday this week. Cell phone lotto winner 14 today. Who's in number 14? All right, guys, last little bit of the period is yours to start on that homework. Let me know if you have questions.